Hello friends, welcome to our first video of Introduction to Signals and Systems and what is the use of signals and systems in the real world apart from passing our semester exams in the university. Let's start. First of all, the first question that comes in our mind is what is a signal? A signal consists of a set of information or data that is actually a mathematical representation of a physical quantity. It means suppose there is a signal, means suppose there is a physical quantity like voltage, current, speech, that is in audio, image. So each of these quantities are represented mathematically by signal. To explain this, let's take a small diagram. Our traditional voltage current circuit. This is the voltage Vt. Now this is the resistor R. The current It flows by it. We all know by Ohm's law Vt equal to It into R, where Vt and It are two analog signal, we can say, that depends upon an independent variable time t. Let's say graphically. Suppose this is our voltage signal Vt. Depends upon independent variable time t, and this is our dependent variable Vt that varies according to time t. It takes different set of values for different values of time t. So we can say that Vt is a signal which consists of different set of values for different values of time. So this is the simple explanation of what is a signal in the simplest form. Now, since it is an intro video, let's go to our next question, that where the signal is actually used in real world. Signal is actually used in modeling of some of the complex systems. The systems can be control system, communication system, image processing systems. Now, we are going to learn about all this in our engineering curriculums as different subjects. To just answer our one question, that how signal is used to modeling of the complex system mathematically, let us take any system. Let's take a control system here. Suppose we are taking here now the block diagram of an automated air conditioning systems, as now summer going on. So our air conditioning system takes desired temperature. Suppose a person requires only 25 degrees Celsius as his desired temperature. So our system takes dt as the desired temperature as one input. Then this goes to a microcontroller. In the microcontroller, our system takes another signal, that is the room temperature. Suppose RT as the second signal, then this two input goes to our conventional air conditioner. It generates output OT and it again comes back as a feedback to our summing point. This is the block diagram of an automated air conditioning system designed to reduce the energy consumption. How? Since our system takes the desired temperature dT by the person, suppose it is 25 degrees Celsius, and the room temperature RT, our microcontroller will adjust accordingly how much temperature is required actually by the person and adjusting the system accordingly to save the excess energy. So this system is a smart air conditioning system. As we can see, this is a complex system, and here we use two signals DT and RT, room temperature signals, to generate a smart air conditioning system. So friends, here now we can now relate little that how important is to know the signals and systems techniques so that we can solve this complex engineering problems in our day-to-day life. So the whole idea of this video was to my whole idea of creating this video was to make you familiar with why we need to study signals and systems and what is the use in a broad spectrum, what is the use of this subject in our engineering journey. So studying signals and systems help us learn the tools and techniques to solve the complex engineering problems by modeling, analyzing, as we can see in our previous small example, designing and optimizing various systems.